Okay, so we're going to look at nerve cells, and the key to nerve cells and understanding how they change as far as the voltage change and when they're going to fire is knowing the starting point. You want to know the starting point really well. If you know the starting point, you won't have an issue moving forward. So in the starting point we see here, we have 2 potassium ions inside, 3 sodium ions outside. Of course, there's more potassium, more sodium, but this is the sodium potassium pump that's working all the time. It's pumping out 3 sodiums extracellular and pumping 2 potassiums intracellular, intra meaning within, X outside, outside of the cell. And this is going on all the time and it uses energy. And as a result, the cells at rest have a negative charge. You could say, oh, they're more positive extracellular, the environment, but we say it's negative intracellular, and that's how we refer to it. There's also negative proteins in here establishing this negative charge. So that's at rest. It's negative intracellular. Well, when a sensory neuron gets stimulated, and I don't know if you could see it real well in this image, but this person has brought the hammer down, it's hit their thumb. The sodium channels are going to open. And as the sodium flows in, it's becoming less negative. Hence, I made the negative symbol smaller. If the stimulus is strong enough, the sodium channels are going to go, more sodium channels are going to open, and eventually it's going to reach what's called threshold. So let's say it went from negative 70 millivolts at rest to negative 55 millivolts, reaching threshold. And when it reaches threshold, it's going to fire. It's going to fire. It's going to fire what's called an action potential. At that point, the intracellular environment has become positive because it'll go from negative 70, negative 55 millivolts to about plus 30, plus 35 millivolts in the change in charge intracellular. And then as after firing and reaching action potential, the cell is going to return to its original state, its polarized state. And to do that, we see there's a tremendous outflow of potassium here to do that, making it very negative intracellular, and to the point where it may be hyperpolarized and then return back to the negative resting potential of negative 70 millivolts. Let's take a look at the notes. So we see here the sodium potassium pump maintaining the cells at rest, pumping out 3 sodiums into the extracellular environment, pumping 2 potassiums intracellular all the time, and this requires energy, ATP. At rest, our cells are negative intracellular. When the neuron is stimulated, sodium channels open, it's going to become less negative intracellular. It's depolarizing, approaching zero. And then here we could see now it's very severe stimulus, highly stimulated. And as a result, sodium channels are wide open, making the intracellular environment positive because once it reaches threshold, it will fire an action potential and the intracellular will be positive, the intracellular environment. And then to repolarize, we see this tremendous outflow of potassium, which is going to create a very negative environment inside, point where it could become hyperpolarized. Let's say it drops down to about negative 90 millivolts, and then returning the sodium potassium pump is going to help in returning it to that polarized resting state. Repolarization, the intracellular, is negative. All right, you ready to do this without the notes? Here we go. So the sodium potassium pump is maintaining the cells at rest, pumping out 3 sodiums into the extracellular environment, 2 potassiums into the intracellular environment. Intracellular, the cell is negative. When stimulated sodium channels are open, it becomes less negative intracellular. When stimulated significantly, more sodium channels open to the point where it reaches threshold, and it will fire an action potential. And at that point, the intracellular environment is positive. Then to return to the resting state, the potassium channels are opening, significant amount of potassium is flowing out, making it very negative. It'll go to a hyperpolarized state and then return to a resting polarized state where the intracellular environment is negative with help of the sodium potassium pump. Thank you for joining me today.